Hello, welcome to Zigmatech Learning Hub. I'll be your instructor for geography. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, Carbopedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So, in today's lesson, we are going to be looking at rocks, and we are going to look at the major types of rocks we have. We are going to look at the characteristics of these types of rocks, which is igneous, sedimentary, and metamorphic. We're also going to be looking at the structure of the igneous rock, the sedimentary rock, and the metamorphic rock. And we will look at the processes that are involved in the formation of these types of rocks. And then we're going to look at the importance and the advantages of rocks to man. So, before we look at rocks, now if you look at the structure of the Earth, or will I say the lithosphere to be precise, you will discover that the lithosphere is the solid part of the Earth's crust. And this lithosphere is actually made up of minerals that are combined together, or we say aggregate of what? Of minerals. Now, this aggregate of minerals is what we refer to as what? As a rock. So, a rock can simply be defined as the aggregate of minerals, or two or more minerals combined together. So, when you combine two or more mineral substances, we actually get the formation of what? Of a rock. And these minerals may be, elements, that we have in the periodic table. So, a rock can be hard or soft. It can be permeable or impermeable. That means water or fluid can go through it or cannot go through it. And examples of kind of rocks we have, we have things like gravel, we have sand, we have clay. These are rocks, and they contain what? Various minerals like silicon, magnesium, aluminum, and the rest. So, let's look at what a mineral is. Now, a mineral is simply an inorganic substance with a fixed, chemical composition or a fixed type of structure. So minerals, they are actually rich in elements that we actually know about. Elements like oxygen, elements like silicon, elements like magnesium, elements like calcium, phosphorus, potassium, and the rest. So these elements are actually found, below the Earth, or will I say they are found within the lithosphere of the Earth, and they combine together to give us what we call rock, as you can see on the screen that is being displayed. This is an example of a rock that is made up of minerals. So it means that the mineral that this rock is composed on is different from the mineral this one is composed on, and different from this other rock that we have too. So let's look at the classification of rocks. Rocks are actually classified into three categories. The first is the igneous rock. The second category is called the sedimentary rock, and the third category of rock is actually called the metamorphic rock. So we're going to look at these three classification one after the other. So let's look at the igneous rock. Now, the word igneous is actually derived from a Latin word which is ignis, which simply refers to fire. So ignis, fire. That's how igneous rock is derived. So igneous rock is actually derived from a hot molten substance we call what? We call magma. So when we have magma ejecting from the base of the Earth, or the core of the Earth, to the surface or beneath the surface, and after that it solidifies, that solidification at the surface of the Earth, or beneath the surface of the Earth, is what we call what? Igneous rock. So when a molten lava or magma goes through the magma chamber, down to the surface of the earth and it solidifies there, whatsoever is formed there is an igneous what? Igneous rock. So a molten magma is actually what? A material that is found beneath the earth's surface, from which igneous rocks are what? Are formed. So this is a typical example of such ejection. As you can see on the screen, we have what? We have lava coming through the vent to the what? To the surface of the earth. Now, when this molten magma or lava solidifies on the earth's surface, what the hard substance that is formed is actually called what? It's actually called the igneous what? The igneous rock. So let's look at the mode of formation. Now, the first thing that will happen when it's formed is that the magma will come right from the source below the earth through the vent, you know, and once it's coming upwards, now it is definitely going to reach the surface, or if it doesn't reach the surface, it's going to remain beneath, and such we call such intrusive magma or intrusive igneous rock. So when such happens, the magma will solidify. It is going to cool down rapidly or slowly, and the thing that is formed after such process is the what? Is the igneous rock. So if it gets to the top, it's extrusive. If the magma does not get to the top, it stops somewhere beneath the surface, we call that what? An intrusive what? Igneous rock. So what I'm trying to say is that we have what? Two categories of igneous what? Of igneous rock. So the first one is called the extrusive igneous rock, and the second one is called the intrusive igneous what? Igneous rock. So if it's extrusive, we call it volcanic because it erupted from the what? From the magma chamber. But if it's an intrusive ejection of magma, we call such rock a plutonic igneous rock or intrusive igneous what? Igneous rock. So let's look at the extrusive rock and its example. So like I previously said, when it comes towards the surface and rapidly cools, you know, at the surface, that hard substance that has solidified, you know, from the magma is what we call the volcanic what? Igneous rock. So examples of the volcanic igneous rock includes rocks like serpentine, rocks like basalt, to be precise. Then we have andesite, and we have what? Trachyte. These are examples of what? Of the volcanic or extrusive what? Igneous rock. So let's look at the intrusive one, the one that could not, you know, get to the surface before solidification. Now, when we have such movement and is not able to, you know, reach the top before cooling, you know, that type of rock is seen as what? As a plutonic igneous rock or an intrusive igneous rock. So examples of the intrusive or plutonic includes rocks like gabbro, we have dolomite, and we also have the popular granite what? Granite rock, and we have peridotite, which is an intrusive rock and is found in the lithosphere and the mantle of the earth. So one thing is that after a very long time, maybe when we've had continuous, you know, erosion, you know, on the surface of the earth, these intrusive rocks will come over to the what? To the surface, or will be exposed to the surface after a long period of what? Erosion, over a long period of time. So the igneous rock can also be classified based on the content of minerals we have in it. You know, the first one we've looked at is classification based on its location, above or below. Now, we can be classified based on what? Based on its mineral content. Now, when the amount of silica, you know, in it is high or low, we then classify it as what? As acid or basic. So we have 4 classification of what? Of igneous rock based on what? Based on its what? silica content. So the first one is called the acid igneous rock, the second one is called the intermediate igneous rock, the third one is called the basic igneous rock, and the fourth one is called the ultra basic what? Igneous rock. So we're going to look at them one after the other. For the acid igneous rock, you know, when the amount of silica in the igneous rock is very high, such type of igneous rock is referred to as an acid igneous rock. So it actually has a percentage, silica percentage or composition of 66% and above. And one thing about the acid igneous rock is that they are usually light in color whenever you see them. An example of an acid igneous rock is granite and rhyolite. These rocks are actually rich in a high content. They have a high content of silica in it, and they are usually light in color. But if you look at the intermediate igneous rock, now this is slightly below the acid igneous rock, so they have a lesser amount of silica, ranging from 52 to 66% of silica. And a good example of the intermediate igneous rock is diorite and andesite. Now these two rocks are actually rich in a lesser amount of silica compared to granite and rhyolite. So let's look at the third one, which is the opposite of the acid igneous rock in terms of silica composition. Now we call them the basic igneous rock, and they contain about 45 to 52% of silica. They are actually denser and darker when you compare them to the acid igneous rock. A good example of this, as we have, is the gabbro rock and the basalt rock. As you can see on the screen, that's a typical example of a gabbro and how it looks like. So when these basic rocks are actually darker, you know, slightly darker than the acid rock, and they are heavier than the acid igneous rock. Then we have the least or the lowest with silica. We call it the ultra basic igneous rock. Now they have silica composition less than 45%, and examples are serpentinite. We have peridotite, and they are usually dark and denser when you compare them to the intermediate and the acid igneous rock. So let's look at the characteristics of igneous rock. What are the features? What can we use to separate the igneous rock from the sedimentary and metamorphic rock? Now, for igneous rock, they are always formed whenever solid magma solidifies and cools down. So they are formed from the solidification and cooling of molten magma. Their composition, their nature per se depends on the composition. So it depends on the silica content, how rich the rock is in silica or not. So for an igneous rock to be darker, it means that it must have lesser amount of silica. For it to be lighter, it must have a greater amount of silica. So their character depends on what? On its chemical composition, or the amount of minerals that is found in such a particular igneous rock. And it is heavy in weight and light in color when rich in in silica. And the reverse is the case. It's dark in color and heavy in weight when there is no silica. So such type of rock that is dark, we call them basic. The ones that are light, we call them acid igneous rock. And when they cool below the earth's surface, we call them intrusive, and when they cool above, we call them extrusive. And they are actually, during cooling or solidification, it is usually fast, and it's usually glassy and fine-grained, when it cools at the surface. And one thing about igneous rock is that they are crystalline in nature because they contain individual grains or individual particles that are in form of crystals. Also, these grains are actually arranged in a manner following. They don't follow any pattern. So they are not like the sedimentary rock that are actually stratified. These ones, they don't follow any pattern. The grains are arranged in a random manner, and also they can contain joints or cracks. After solidification, they can contain different fissures or different cracks on their on their surface. So like I previously said, they are not stratified, they don't occur in layers compared to the other type of rock, and they don't contain fossil because they are actually made from solid magma. And this type of rock are actually hard and resistant to weathering and erosion. So we look at the next type of rock, which is called the sedimentary rock. Now, the sedimentary rock are actually formed from weathered materials. As the name implies, sediments are actually remains or leftovers. So they actually formed after weathering has happened. So what happens during weathering or denudation is that water or any agent of denudation we carry this weathered rock from one location to another. So after that, during deposition, we have what they call lithification. So lithification of these loose rock, these loose materials will give us what? Will give us a sedimentary type of rock. So we can say that these rocks are actually formed from the lithification of loose materials that are gotten from debris, organic matters, or materials that that originated from sea water. And one thing about the sedimentary rock is that they are actually stratified, or they occur in layers. And this the plane between these two layers, we actually call them a bedding plane. The plane we have between a layer of sedimentary rock and the other layer of sedimentary rock is actually called a bedding plane. So they are actually lying along the bedding plane. So how are sedimentary rocks formed? They are actually formed from debris or weathered materials or fragments or organic matter. Now, when these materials are actually eroded from where they are, from their source, or will I say from the point of weathering, now they settle up somewhere, and they are formed in layers or strata. They are compressed, they are lithified, they are cemented together till they give a sedimentary type of rock. So as you can see on the screen, we have an example of what a sedimentary rock look like. As you can see, we have a conglomerate of a sandstone on the screen. So this is just a typical example of what sedimentary rock is. So these weathered rocks, they've been lithified and compressed together to give an entire structure, which is a sedimentary rock. So if you look at the sedimentary cycle, now a cycle is just simply a complete movement, in a circular manner, from beginning to the end and back to the beginning. So let's look at this sedimentary cycle of sedimentary rocks. Now, the first thing that happens before a sedimentary rock can be formed is weathering. This weathering has to do with breakdown of rocks or bigger rock materials or fragments. Now, when breakdown has happened, erosion will take place. Now, when these weathered rocks are being eroded by any agent of denudation, now they are transported to somewhere and they finally turn into a sedimentary rock. Now, after that, the weathering will take place again, and the cycle will continue. Now, this cycle of weathering, erosion, sedimentary rock formation, weathering, erosion is actually called the sedimentary cycle. So we call this complete movement a sedimentary cycle. Now, sedimentary rocks are classified in three categories. The first one is called the mechanically formed sedimentary rocks. The second category of sedimentary rock are the ones that chemically formed, while the third ones are the ones that organically formed. So mechanically formed sedimentary rocks, chemically formed sedimentary rocks, then we have the organically formed sedimentary rocks. Now let's look at the ones that are mechanically formed. Now when we say a rock is mechanically formed, that means it's actually formed from by physical action or physical process. So in this type of formation, we just have eroded materials or debris or fragments being compressed and cemented together or lithified together by by the action of rain, wind, and ice. Then for the categories of mechanically formed sedimentary rock, we have three categories. Now, the first one is the clayey rocks, the second one is the one that is coarse in nature, and the third one is the one that is what, sandy in nature. So the clay category, we actually call it clayey rock, or we call it argillaceous what type of sediment, mechanically formed sedimentary rock. Then the second one, which is coarse grained, we can also call it the rudiceous what type of rock that is mechanically formed. Then the third one, that is sandy, if you don't call it sandy mechanically formed sedimentary rock, you can as well refer to it as the arenaceous what type of rock. Now, examples of the argillaceous or clay type of rock is the mud or the clay or the mud stone and the shale. These are sedimentary rocks that are mechanically formed and they have a clay what nature. Then for the rudiceous or the coarse one, we have gravel and screes, that is gotten from exfoliation of rocks. Then we also have the arenaceous examples as sand, sandstone, conglomerates, and also have grits. These ones are actually sandy, when you touch them. These sedimentary rocks are actually sandy when they are being felt with the hand. So let's look at the sedimentary rocks that are formed chemically. Now, when we say sedimentary rocks are actually formed chemically, they are actually formed as a result of some chemical reactions, that happen, after after the erosion and deposition of these rock materials. So some of the rocks of these sedimentary rocks are formed when materials, that dissolve in water precipitate out. So the chemical reaction will give rise to the formation of these rock. Let's take, for instance, gypsum and potash, like potash we have on the screen here, right here. This is an example of a chemically formed sedimentary rocks. Now, these rocks are actually formed from, apart from dissolution, they actually formed from other chemical reaction or chemical processes like solution, carbonation, and the rest of them. So when these processes, this chemical reaction, is involved in this process, in this sedimentary rock formation process, such type of rock is seen as a chemically formed sedimentary rock. So examples of chemically formed sedimentary rocks include gypsum, nitrates, potash, and sulfates. So those type of sedimentary rocks are called chemically formed sedimentary rock. Then we look at the third classification of sedimentary rock. We call them the organically formed sedimentary rock. Now, these rocks are actually formed from the remains of dead organisms. When dead organisms, they decay and decompose and they later form soil and liquefy together. This rock that is being formed from it is an organically formed type of sedimentary rock. And the dead organisms can be plants, it can be animals, it can be shells or bones or any living organisms that that has decayed. And after the decay, they will compress together, liquefy, and cement each other to form this rock. Example of such is things like coal, like lignite, like peat. These are limestone. These are organically formed sedimentary rocks that we have. So let's look at an example of an organically formed sedimentary rock. Now, if you look at the screen, we have limestone and lignite. This is a limestone rock, and this is a lignite type of rock. And limestone rocks are actually found in places where we call the karst region. So that's for the three categories of sedimentary rock. Now let's look at the characteristics or the qualities of sedimentary rock. Now, the first one is that sedimentary rocks are actually existing in layers or strata. So they are made up of sediments that are laid down in layers, and these layers we call them strata. And since they are in layers or strata, we can say that they are stratified. And the next characteristic of sedimentary rocks is that some of them contain fossils. So sedimentary rocks are fossilized and they don't contain crystals when you compare them with the igneous rock. So sedimentary rock can be hard or soft. They don't contain crystal and they can either be made mechanically, they can be made organically, or they can be made what? Chemically. So these three processes actually give rise to the formation of a sedimentary rock. And also, a sedimentary rock may be coarse in nature, may be fine or grained, and their strata, varies in terms of what? In terms of thickness. And during erosion, these sedimentary rocks can actually be weathered off or can be what? Eroded off. And they are actually formed from a pre-existing type of what? Of rock. And this pre-existing rock can be an igneous rock or a sedimentary what? Type of rock. And when the pre-existing rock is being broken down, it is what? Carried away through erosion and deposited either by wind, by water, or by what? By ice. So, what are the uses of sedimentary rocks? Now, sedimentary rocks are actually used for construction, like we have the sand and sandstone, we use them for construction, and some of them contain what? Contain minerals, like the organic type of sedimentary rock. So when you bore through them a hole, you're going to extract some form of what? Minerals like crude oil. And they serve as what? As a reservoir for groundwater. Some of these sedimentary rocks, where we have them located on the earth, can be used as a tourist center, and we can also use them for scientific research purposes. In terms of cooking, we make use of a sedimentary rock, which we all know as salt or table salt. And the industrial use is that we apply it in the industry to manufacture cement, which is the limestone we use for making what? Cement for building and for construction. So let's look at the third type of rock. And the third type of rock is actually called the metamorphic rock. Now, when we say metamorphic, we're actually talking about transformation that has happened from an object A being transformed to another object B. So metamorphic rock are actually rocks that are formed from pre-existing rock, and they are actually formed as a result of heat or pressure on the what? On the pre-existing rock. So these two factors are actually considered whenever we are talking about metamorphic rock. If it's not heat, it's going to be what? Pressure, or it will be both of them. So the existing rock can either be a sedimentary rock, or can either be an igneous rock, or it can even be a metamorphic rock. Now, when this sedimentary or igneous or metamorphic rock is subjected to intense pressure or heat, the transformation that happens, or the final type of rock that is being formed, is a metamorphic rock. And another name for metamorphic rock is a changed rock. So we can if you don't want to call it a metamorphic rock, you can as well call it a changed type of rock. So during the process of transformation or metamorphism, the rock that is being subjected to intense heat or intense pressure, or both factors, will not melt. Now, the moment such a particular type of rock should go through a melting stage, we call it an igneous rock. Yes, so during this process of intense heat subjection or pressure subjection, the rock is not going to melt or turn to magma. Instead, it will just transform to what? To a new type of rock. So that's the slight difference, between the process of igneous rock formation and metamorphic rock formation. So we have examples of metamorphic rocks. We have things like quartzite, we have gneiss, we have marble, slate, graphite, and schist. So let's look at how it is formed. Like I said, we have it can be formed from what? Igneous or metamorphic or sedimentary, and it will be subjected to what? To heat or pressure, or a combination of both of them. So the changes that will happen in the structure is what will give rise to the formation of what? Of a metamorphic rock. So when this when this rock is subjected to intense heat and pressure, the structure, the chemical structure or the mineral composition of that rock will definitely change, and what is formed next is what we call the metamorphic rock. So we have some common examples of the metamorphic rock, and as you can see here, we have a marble, and we have a quartzite here, a quartzite rock. We have a graphite type of rock, and we have a gneiss type of rocks. Now, the common thing about these rocks is that they are actually formed from the transformation of other types of rock, like limestone being transformed to what? To give us to a marble. So we're going to look at this transformation bit of this igneous and sedimentary rock, giving us a metamorphic rock as we go to the next to the next slide. So here we have the existing rock, and after the intense heat and intense pressure subjection, we'll have a new type of rock being formed. So let's look at them one after the other. Now, if you look at clay, when clay is being transformed to a metamorphic rock, we end up having a slate. So clay gives rise to the formation of a slate, limestone gives rise to the formation of marble, sandstone gives rise to the formation of quartzite, granite gives rise to the formation of gneiss, shale gives rise to the formation of schist, and coal gives rise to the formation of graphite. Then we also have basalt being transformed to either schist or a gneiss type of metamorphic rock. Now, metamorphic rocks are actually classified into three categories. Now, they are classified based on dynamic or regional metamorphism. Then, if it's caused by heat, we call it a thermal metamorphic rock. Then, if it's caused by pressure, heat and pressure, we call it a thermodynamic metamorphic rock. So the first one is actually caused by pressure, which is the regional or dynamic metamorphic rock. An example of such type of rock that is caused as a result of intense pressure is gneiss, we have schist, and we have slate. Then the ones that are actually caused by intense action of heat, we have examples like marble, like quartzite and hornfels. Then a type of metamorphic rock that is caused by both heat and pressure is like quartzite. We have it as as a type of rock that is caused by this feature. So let's look at the characteristics of metamorphic rock. Now, metamorphic rocks are actually formed from intense heat or pressure, or both of them, and their feature depends on the type of rock that is being transformed, if it's an igneous rock or if it's a sedimentary rock. So if it's formed from a sedimentary rock, it's definitely going to have some sedimentary rock features. But if it's formed from igneous, it's definitely going to have an igneous rock feature after transformation. And they are actually harder or compact than the original rock because of the pressure and the heat. And the mineral composition of this rock, they actually change, or transform without melting. Because I told you previously that if it melts, it's no longer a metamorphic rock, but definitely an igneous rock. So this mineral composition in this rock during the process of metamorphism will transform without melting. And they are actually a hard and more resistant type of rock. So metamorphic rocks are actually resistant to erosion and weathering, and they are actually very hard. And some of them may not contain fossil, especially if they are formed from igneous rocks, and they may not occur in layers if they are formed from igneous rocks, or they occur in layers if they are formed from sedimentary rocks. So this is a typical example of how the rock cycle is. Now we have the igneous rock, formed from the solid magma. Now when it breaks down through weathering and erosion, the sediments will liquefy to give us a sedimentary rock, and this is the sedimentary rock we have here. So after lithification and cementing of that sediment, we have the sedimentary rock. Then if this rock is subjected to intense heat and pressure, it will give rise to the formation of a metamorphic rock. And also the igneous rock can directly be converted to metamorphic rock if it's subjected to heat and pressure. And in process of melting, below the crust, some of this metamorphic rock can as well go back to being called magma, and the cycle repeats itself. So that cycle is actually called the rock cycle. So we look at the importance of rocks. What are rocks used for? Number one, we use them for building stones that we use for building objects, or bridges or whatever. Those stones are actually gotten from rocks. And industrial raw materials can be obtained from these rocks. be it metamorphic or sedimentary or igneous rock. These rocks are also sources of minerals. They can be used as ornamental stones. They can be used for road construction and building construction. And a sedimentary type of rock, which is coal, is also used as fuel, for industries and also in some houses. Limestone, which is a sedimentary rock, is used for the manufacturing of cement. And dolomite and marble are used whenever they are manufacturing what? Paint or glass. So these are some of the importance. Now let's look at the disadvantages or problems of these rocks. Now, when we have rocks around, they end up occupying or taking away spaces that we can use for other human activities. So this is a disadvantage. And their obstacles, they obstruct the free flow of movement, either for human beings or even for water, like a water route. They can also occupy spaces that we are meant to dwell in, like places where we can build houses. A rock can easily occupy such a land. And enemies or criminals can hide around those places where we have rocks there. So rocks can can hide enemies and can also hinder effective communication, because when we have places where we have masts, communication masts, these rocks can serve as a barrier, hindering the connection between masts and our mobile devices. And rocks can serve as a barrier, between different towns and villages, so preventing intervisibility between these two towns and two villages. So let's quickly go to the exam guide. Let's look at some questions. So we start with let's look at the UTME to be precise. Let's pick a question from 2009 UTME. Let's look at 2009. Okay, I have 2009 here. So let's look at question number 13. Let's look at question number 13. Now, if you look at this, we have limestone and clay are metamorphosed into dash. Now we have A, we have marble and gneiss, we have marble and slate, we have graphite and quartzite, we have graphite and gypsum. Now, from my explanation, when we look at the table of metamorphic rocks, we discovered that limestone can be transformed to marble and clay can be transformed to slate. So the correct answer there is option B. So let's look at another question in the UTME 2013. Let's look at question 2013. Let's look at year 2013. So we look at question number 10. Let's look at question number 10. Now it says, which of the following rocks is suitable for the construction of roads and building purposes? Now we have A, limestone, B, basalt, C, granite, D, graphite. Now the question says construction of roads and building of building purposes. Now if you look at B, basalt is off. We don't use basalt, we don't use granite, graphite to build or construct. So the correct answer will be limestone, which is we use for the manufacturing of cement, and this cement is actually used whenever we are constructing or building. So we take the next question. Let's take from the SSCE. Let's look at year 2015. Let's go to 2015. Let's look at question number 18. Now, question number 18 says, which of the following is a characteristic of igneous rock? Now, A says loose in composition, B is arranged in layers, C is crystalline in nature, D is porous in granular structure. So I think the correct answer there should be should be option C, because they are They are crystalline in nature and they don't occur in layers when you compare them to the sedimentary type of rock. So with that, we've come to the end of this topic, and so far in today's lesson we've looked at the nature of rocks, we've looked at the meaning of rocks, and we've seen the types of rocks and their mode of formation and characteristics. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.